So thanks for joining this morning, everyone. I think there's a theme of UI talks happening at 9 a.m. at CppCon this year, so I'm glad everyone's here. Hope you've had enough coffee to look at some templates and other stuff today. A little bit about me. I'm Roth. I'm a principal software engineer at Native Instruments, which is a big family of music companies that have joined together over the past few years. Isotope, Native Instruments, Plugin Alliance, and Brainworks. I come originally from the Isotope side of the family on the Boston team, but these days work across all the brands on various technology and code sharing topics. And we make software for music and audio production of all sorts. So everything from DJs to software for mixing and mastering records to post-production for film and television, keyboards, synthesizers. If it makes sound or music, we are usually involved in. But this story comes from a few years ago before the merger. So this is just a story from the Isotope side of the family and a journey through developing some of our UI libraries and how we improve some of this. But before we get into that, something I'd like to start all of my talks off with is a call to action for everyone in the audience that if you see someone on stage here at CppCon or on YouTube giving a talk, we're not some like magical C++ people that are here giving talks, but we're someone that either learned something or did something and wanted to share it and came here to talk about it. I think everyone here in the audience or listening on YouTube probably has an interesting story or experience from their own either personal projects or their work to share. So I encourage all of you to actually consider speaking at conferences and often conferences have lightning talks, which is a few minute talk and maybe is a nice easy way to ease into this. So I always like to encourage everyone to try this out someday. And so we have a bigger community of speakers. But back to the topic of hand. No, this slide, this has the wrong year on it. It's because I gave this talk before in 2021. And after I gave the talk, about a year or so later, I get this comment on YouTube. A lot of this could have been solved with C++20 concepts. Yes, this is true, and I actually almost put a slide about this at the end of the talk last time, but I had never used concepts for real because I did this in 2018, so we did not have C++20, and even by the time I gave the talk, Apple Clang that we were using didn't have concepts yet either, so I wasn't about to, be teaching something I hadn't used myself yet. So now we have the Reprise, where we'll do the same topic again, but instead of learning about Sphinx and other dark magic of template metaprogramming, we'll use concepts, so this will be a lot easier to explain. And so one of the things we're gonna be talking about, if you've read the abstract, is one part of this GUI library that we're gonna use as an example in the code today is our property system. And what do I mean by a property system? I mean a way to give objects that they have synthesized storage of member variables and synthesized getters and setters. And the object will need to have some notification of knowing that, oh, some property changed, I might need to do something, like repaint myself or something like this. And also, it would be good to be able to serialize these properties out to maybe XML or other ways of serializing the UI instead of just specifying everything in C++. And some examples of properties from other languages, Objective-C has this ability to, in the interface, have an @property declaration, and this will synthesize getters and setters for the background, the text and background color, both the methods as well as the member variable storage for this. Swift has something similar, a little bit nicer syntax where we can have a string and say, oh, when it's set, do these things and call these methods. So where are we going with developing a property system like this in C++? When I started, I kind of dreamed of having something like this. Yes, we have a macro here, but really the key here is, notice all these parens. I'm a Lisper at heart, and so I kind of dreamed of declaring UIs as just Lisp data structures and rendering all that out is kind of an ultimate dream I've had for many years, but that's not the thing here today. But a little piece of this is wanting this very simple declarative syntax. We're saying these are the properties that something has, and then applying those properties to a button. And we'd use them something like this. We can make a button, and then this button will automatically have set property methods that can be templated on these various properties that were described here in this declaration. And then within the class, you might use them in your draw function. You might have some box filling and drawing text, and then you can get properties out with the synthesized get properties. And so this is a story about rewriting or version 2 of an internal UI library. And to understand why we're even thinking about building our own UI libraries, it's maybe important to understand what it is like as life as a plugin. In my case, an audio plugin, but this could apply for other plugins where you're making code that's going to run in somebody else's process, and there's a number of challenges with this. You could have multiple instantiations of the same plugin, which means global variables, global state is not something you can have in your library, and this might impact what third-party libraries are possible to use because they're designed for applications. There might be some global app state and stuff, and you can't do that in a plugin because you have two instances of it loaded. They'd be sharing the same global variables. There's lots of ways that you actually get on screen when you're an audio plugin. Sometimes the host application will give you a window to present yourself in. Other times, it will tell you to give it the window you want to draw in. And then there's also performance considerations. We have many, many UIs running at once. We want metering running at high frame rates, ideally v-synced with your display so you get nice, smooth metering. And users also need very responsive controls in the UI to be able to, hear the sound as soon as they move a knob. So this all needs to, care about performance a lot. And the threading model is really complicated when you work in these plugin hosts because there's some document, this happens on this thread, this happens on this thread. But other APIs is, hosts can do whatever they want, call you however they want. So there's a lot of threading complications we deal with as well. So this is some background and why we had tough decisions to make when thinking about upgrading our internal libraries or adopting third-party UI libraries. So a little bit of history. When iZotope was founded, they, I think, were looking into using Qt originally back in the day when they were making their first product as a Winamp plugin, but getting into proper desktop plugins, Qt was for applications and had a lot of global state and just does not work in plugins. So they started writing their own UI library called Canvas. This was right before the most popular framework for making audio plugins and applications, Juice, started to begin its life. So this was not an option for us today. If you're building plugins now, I don't recommend you build your own UI framework. Start with Juice. It's, I think, probably 70 to 80% of the plugins out there are made this way. If you're starting today, if you're starting 25, 30 years ago, we don't have these options. And then we did look at Qt. Around 2014, some work was done in Qt to make it work in plugins. And we were told in 2018 when we started this rewrite of our libraries that, they told us, this should work in plugins. It's not really documented, but you do this and this. And it seemed maybe true, but we didn't really believe it. Now that we've merged with NI, we know that, there is ways to get Qt to work in plugins. But the reason this question mark is here, it's still officially not supported. We just know how to make it work. And there's rumors maybe someday Qt will actually officially support this, but that's why we decided we didn't have these other options and kind of were working in our own world. And starting in 2002, with the founders making this library, over time, Canvas, our UI library, grew into this organic monster where, I need an API for this, so I'll add this one here, and this here, and this here. And all of a sudden, the API surface area is huge. There's so many different ways to do things. It's really hard to learn, lots of opportunities for bugs. And I'm not blaming any of my former colleagues for, they made some bad code. This is all pragmatic decisions made to deliver business and user value for a long, long time, and it worked great for the company. And the reason this picture's here, it's blurry because it was taken off a wiki of low resolution, but also I guess protects my coworkers' identities. But you can't tell, but that is me here. And my point is, some of the gross things in our old Canvas library, I added in the year before we started this new project to upgrade things. So how did we want to deal with organic monster? Initially, I was proposing, let's just drop it all, switch to Juice or Qt or something. And there's a lot of reasons why we decided that actually isn't the right solution for us. Let's do a rewrite instead. Now, I know that probably sounds really scary. A software rewrite project, that's probably gonna fail. But why were we bold enough to do this? We had a lot of features that we liked and wanted to keep taking advantage of. We already had a way in our Canvas library to serialize and deserialize UIs in an XML layout file. And this is really good for having designers be able to edit things and not need to deal with C++. We also had a style sheet system. Doesn't have the complexity of cascading style sheets, and it's JSON, it's a little bit weird, but this was also useful. But the particularly useful thing is with those XML layout files, we also have a interactive debugger and layout file editor. So you can open a running product, open this editor, and you see I'm changing color values, and this meter is changing. And then speaking of metering, we also had a really nice high performance v-synced metering library written in this framework that we also did not want to lose. And then in every other library we looked at, which string do we want to use? We already had our capital S string in the global namespace from decades ago. And a lot of the other UI libraries, also being old, had their own strings. Like, do we really want to have more library-specific garbage? Or wouldn't it be nice if we could just actually work with modern C++, like standard string? So we decided to keep these things and focus on using modern C++ instead of taking more legacy like our legacy baggage plus someone else's legacy baggage. We decided to pursue our own library. And the other advantage of that is we had a very good control over the interop story because we controlled the old library and the new library, and we could design this with ways to mix and match. So we decided to make a new library called Glass. One of our designers named this. It's called Glass because that's what windows are made out of. It's only pun for today, I think. And someone called that out on YouTube as well, even though I did say this in the last time I gave the talk. When I say rewrite, we did not actually rewrite the whole thing. I call this a porcelain rewrite, where this is a abbreviated version of what kind of the tech stack looked like for Canvas. We have a bunch of third-party libraries, AGG for drawing, FreeType for text, libpng, some other stuff like that. IZBase is kind of our general foundational application library. And on top of all this, we had Canvas, our UI library. And instead of rewriting all of that, we decided to use that as the engine to build a new library where we could make new APIs, Glass, and then integrate the other new features that we wanted that didn't exist in Glass. So we wanted a automatic layout engine. So we brought in the yoga library from Facebook with patches to get rid of all their global variables, because we're plugins. The Skia library from Google Chrome for drawing, and this new Sparkle Motion library we had developed for metering. And by combining all of this together, we allowed us to make new APIs that are easier to learn and safer, and eventually replace more and more parts of the engine underneath to support new features we needed. And then part of that also is this GlassProperties library, which we're going to talk about today, that took some features in IZBase and Canvas that for our existing property system that supported the XML layout files, the design editor, et cetera, but all had runtime errors. And so this is what we're going to talk about today, how we took those runtime errors and made a much nicer and easier to use and much more powerful API. Before we get into that, just one other aside about actually how to get big infrastructure projects like this done. Because if I have this, I don't know, this kind of says that you're finished if you wait to finish. And the point is that maybe you should never be finishing this stuff. If we actually said, like, okay, we're going to write this library and then start building products with it, I don't think this would have ever succeeded. We didn't ask for a specific budget that, we're going to take engineering time to build this library. But for each product release on the roadmap, we included, part of the library in that development roadmap. So the first product, Insight, is a metering product, and it used a very early version of this library Glass, just a layout engine that allowed us to lay out our old UI library. And then we had Vocal Doubler, and then Nectar is where we really, in this, our main vocal product, we decided to put a lot of time in actually building out most of that UI in the new library. We built most of the features we needed. One example is something we didn't build a slider because the initial version of the UX only had knobs. So we just built knobs at the time, built sliders later when we needed. And then as we released more products over time, we would start replacing layers in that. And over time, as we release more and more products, each release, NeoVerb, this one as a new reverb was basically all built in Glass. And at this point, most of our product line has made it through the evolution. But the nice story of that interop is we never had to go one way or the other. We were still able to use any of our old widgets or meters or tools within this new library. So specifically talking about this property system, what was wrong with the system we already had in Canvas, the old library? Two main things. One, it was imperative. And by being imperative, it meant that you could choose to do weird things like conditionally declare properties and things like this. And also, it was not type safe. So there was a lot of runtime error checking. So this is what it kind of looked like in the old system when you'd set up properties. You might have some, this is kind of to show you might have some view-based class from Canvas that inherits from something called property holder and trackable. We'll talk about that in a minute. And then your button, one of the first things you're going to do is declare a bunch of constants for string names for all your properties. And one of the kind of weird things about this is this trackable. That's something you must inherit from to make property notifications work correctly. And actually inheriting from it could lead to subtle bugs versus having it as a member. Don't really worry about that. That's not germane, but that's a strange thing we want to abstract and hide away. And then property holder, this is the kind of thing which is essentially a dictionary of strings to boost any's or standard any's that can hold all of the properties for some object. And it had a less than ideal interface. So it had something for creating a property, that's fine. But if you notice, the get property returns an optional. So like, oh, it might not be there. And that's because we're getting it by its string name and having to tell it what type it is. And if we get the type or string wrong, it's going to be optional. And then set property also returns a bool, so setting can also fail. But if we know if the property's all right, none of this should fail. So if you look at get property, it has a number of different checks that it's doing. First, it's seeing, oh, is there a property that matches your name? If not, okay, fail. Then, okay, we found with your name, did you put the right type in the template to do the anycast? If not, oh, okay, we'll fail again. But if you got everything right, then we'll return the right value to you. The other downside is as far as getting notifications of property changes, there was this public API for getting a property signal, which meant that not only does the class itself have the ability to know when its properties change, any part of the code could listen to knowing, oh, I'm gonna be a label over here. I'm gonna listen to when this button's text color changes. And every now and then someone claims they have a good use case for this, but it makes the code really confusing to understand and you have all this spooky action at a distance. And so that's something else I wanted to hide away. And then there's some other public APIs that you really don't want to know about. Get serialized value and set serialized value. That's to support that interactive debugger. No one in C++ should ever call these. You can, and you could do weird stuff for some use cases, and I admit I did it. But again, we want to hide this away because users should not be doing those shenanigans. And then we'll get into more problems. Like I said, we have to declare string constants for all of the property names. And then when we create the properties, you notice we're repeating ourselves. We say create property, and we say the type is a string, and then we have another constant that is the name of the property saying string. Then we say color, and then the string color, and we're repeating ourselves here. And that's another opportunity on creating, setting, or getting that you can mix up those type and strings and not get the results you want. And then if you look at, when we're actually, let's say we connect to some property signal and we get a property, and I said, oh, we get an optional, and we have to assert that, yeah, the get property works. And it's even worse because we weren't using standard optional. It's our own optional that has implicit conversions to default values. So in this case, what actually happens is if you pass the wrong name in for this property and it didn't exist, this check value will implicitly convert to an empty string, and you won't actually know anything happened unless you're listening for certain debug asserts. And there's a limited number of types. Everything was essentially, these basic primitive types: points, sizes, recs, colors, strings, images. And what this meant is that anything beyond this, it was just a string. And then people would do their own string parsing in their class to do this. And this is basically, there wasn't really you could define more properties, but the APIs didn't encourage people to do it. And so that was the other thing. I wanted to make it really easy for people to make properties that aren't just a string representing some function somewhere, but you have a property that's a function pointer or any strong types. I want all the properties to be strong types and encourage people to make it really easy to define new property types. So again, the user problems are it's imperative, runtime type mismatches, runtime declarations, confusing signal connections. If you have a property that changes a color, it's your responsibility to know when that changes. I have to write code every time. Oh, this property changed. I need to know. I need to repaint. And it didn't encourage people to make new types. So the solutions: let's make a declarative AI, put all the information in one place so we don't repeat ourselves, make it type safe, compile time errors, and we'll only create properties on construction. That's the other weird thing about doing it imperatively. You could add properties at any point in a class's lifetime, which also made it confusing. So when I was first thinking about how to do this, I did actually see Herb's metaclasses talk from 2017. I thought, oh, that would be really cool. That would solve all my problems, but I need to do this in 2018, so no. And then I started talking to a colleague, oh, maybe I can make something with like M4 or C macros, which there's many gross things about both those technologies, and that's also going down the Qt meta object compiler road. And he was like, no, Roth, please, do not do this. Can we use C++17 and templates instead? I said, yes, okay. And it was a great learning experience because I basically wrote the code how I wanted to use it, and then figured out with my limited knowledge at the time of CNI and some button mashing how to get it to work. And that's actually where a lot of my deep template knowledge came from, was experimenting and figuring out how to make this stuff work. But today, we don't need to talk about any of that dark magic, because we're going to talk about how to do it with C++20 concepts instead. Before we get into my library, just very briefly going to show some slides from another concepts talk I gave, just to get everyone up to speed if you've not used concepts yet. So at a very basic level, concepts are a way to constrain templates on what types they can accept. And there's a number of different places you can put them. So, and everywhere I have C1, C2 in here is a place you could put a concept. So you could put a concept instead of type name or class in your template parameter pack. You could also have this requires clause where you put a concept afterwards, and we'll see some examples later where that's useful. You can use it to say the return type has to match a concept if you do concept auto for the return. Arguments can match a concept if you're using concept auto. And then you can also have a concept requires at the end of your declaration. And this is if you want to use things like the X in your function parameters in the concept. You could do that way. And they're essentially a way of creating overload sets. So imagine we have some functions for dividing stuff by half. We have a generic templated one, and then we have ones for floats, doubles, and long doubles. And the non-double one does some, I think I did that right, like rounding math. Just pretend it's right if it's not. And so you see we have a template and then 3 specific implementations for those 3 different types. But we can start, maybe it's a little better with if const expr. We can say, oh, if it's integral, do this, else do this. But in this case, this is going to have a problem because if we pass a, standard file system here, that also has a slash operator. So we actually want this to work for numbers only. So the way we can do that is instead we can use concepts and say we have one function for integral types, and that's stood integral as a concept for the standard library. And then we have another one for floating point types. And maybe you want this to work with your custom types too. So we can design a new concept called kenhalf. And kenhalf is something that this expression t over t constructed with 2 will return the same type as t. And that requires capital T. That's basically saying like, give me a object, a pretend object in this context of type t. And so we could, first check, does this expression in the braces compile? And then does it match the concept? Is that the same as, are both t's the same? And then we can use this kenhalf to say, oh, this is a kenhalf that requires integral, and then a kenhalf that's our generic version of kenhalf. So, a little bit of overview and concepts. And please, if you have a question or confusion along the way, please raise your hand. I might answer it in line, or we might save it for later as that comes up. So, back to the topic of hand. How are we going to do this with C++20 concepts? So, again, I'm going to show my 2 favorite memes I show to my coworkers when I think we're doing things wrong. One is this example I showed you before where we have to get the correct types for get property and the correct string to get in to make sure that our checked value actually holds something when we pass it in to this ellipsize function. And I screw this up a lot. I saw other people screw this up a lot. And like I said, if you screw this up, you might silently get an empty string in a release build and not realize what's going on. And as HAL 9000 would say, this can only be attributed to human error. So that's goal number 1, reduce the need for human error. The other one I showed you is we're repeating ourselves, naming types and then having string names that correspond to those types. And whenever we're working too hard, I share this scene with my colleagues from Metropolis. If you've not seen this film, I highly recommend it. But there's a theme of humans doing the work to keep machines running. And this is an example of we're doing the work here, we should let the machines do when we repeat ourselves like this. So we don't want to be this guy either. And also, it can be safe. So we deserialize something from a layout file. The deserialization could fail. We know this, sure. But we have invariants set up. We know I created properties with these certain types and names. And so if we enforce that they're always created as we expect, and then synthesize the right getters and setters, we can ensure that while the runtime system underneath has to do all these checks like, oh, does this name exist? Is it the right type? Blah, blah, blah. We can write an API on top to make sure we never call it wrong. And then we always can assert that these optionals are all true. We get no errors. But some of the ways we can have stuff go wrong is, if that class name is wrong in XML, this could give an error. If the property type is nonsense, it could get an error. If we don't put in a value, we could have a problem here. But these are all errors validating the JSON or XMLs to come in. If those fail, then okay, we just fail and we don't set the properties. But if it all succeeds, then we know we're in the right types, and then every setter should succeed. So this can be safe because we can now, from the C++ side, we can know that anytime we're calling set property from C++, if we can enforce that, get rid of these names and enforce that the name and the T always match and always found, these can become compile time errors. And I'll show you what this looks like. So here's where we want to end up, is the way to declaratively describe a property of our button. So we have a text property, and it has a type. Property type is a standard string. It has a name, and it has a default value. We can collect all these properties in another type that we call a property list by putting them in the template parameter pack. And then if our button declares from this special has properties template, or derives from it, and passes this properties list, that will take care of creating all the properties and providing only the getters and setters that need to exist for those properties, and noticing that your class has a didSet function, and also connecting that up so anytime you change the property, that'll be called. And we can see how this works. So really, I want it all in one place, but if you look, these 4 lines, the 3 in the property struct and this didSet, that's all the information we need to describe a property from the class. And maybe not the didSet, even if you don't care about those notifications. And instead of having this be a bunch of imperative calls that can go anywhere, this is now in one place, self-documenting. You can look at the class, know its properties, they're always going to be there, get and set will always work. And so the original version of this, I started with this and figured out, okay, what templates do I actually need to make this work? Now that we're going with concepts, I want to actually recommend a different approach because and get into some more talks, but there's sort of a TDD-ish approach with concepts where instead of writing code first and then having concepts that match it, and this is the full concept for a property description that describes one of these properties. Instead of starting like this, the way I like to begin is first start with an empty thing that doesn't implement your concept and just start adding things. So the first thing we need, okay, a property, it has to have some type called property type, so we know what type it is. And okay, text is going to fail, it doesn't have one. So now we add it, okay, it's passing the concept. Well, we need more than this. We know it also needs a name. And in this case, not just any name, but a name that is convertible to string. Okay, so now we can add this to our property, and we have a name. Static asserts on this will pass again. And then we also want a default value. So again, we're saying there's a T will have a : default value. And again, we want this to be convertible to this property type. And then we can add this as well. But there's one kind of downside here. Property type is just a low-level type like string. But it's possible, maybe string's not the best example, but you could imagine you might want the same type to actually get serialized and deserialized differently depending on its use case. And so the underlying C++ type and the purpose of the type are potentially 2 different things. Also, one of the other goals is have all the information in one place. And so where is the information to know, of course, string's easy, but how do I serialize string? So the fix here is we won't actually have the property type be the actual backing storage, but another struct that we'll call, in this case, we'll call it string property type, and this will be a new concept. And this, and we're going to build this up right now as well. So you see, I made a new concept called property type description. And when I make new concepts, I'll just make it say true. So I can start using it and then build up the concept later. And now you'll see our property description concept below. Instead of just saying, oh, you have a T : property type, we've removed that. And now we say that for T, property type description, that T property type, matches this property type description concept. Right now, that's always going to be true, but we're saying like, okay, this is not just any type, it's a property type description. And then we still have, it requires a name and a default value. And so what does a property type look like? A property type is the backing storage. It has a type. Again, it also has a name that we know for serialization. Yep, string. There might probably fancier ways to do this, but sometimes we want custom names. And then a serialize and deserialize function. And so a concept for this will require us, again, to have a type for the type, t::type. And then it will have a serialize function that can take that type and return something convertible to string. And a deserialize function that takes a string and returns a standard optional of your type. And now notice I didn't do convertible to standard optional. I actually did know it must be a standard optional because ask me in the hallway, we don't have time for it right now, but the template constructor for standard optional that constructs it with anything convertible to the inner type has very strange interactions with implicit conversions from other optional types, and you can get some surprising results. And so, no, I don't want you to give me some type that you think will correctly convert to a stood optional. If you want to know that horror story, I can share that in the hallway. It is another example of another property type. They'll be a little bit more advanced in the string one. For uint, we have a serialize. We'll use format to do this, and we'll use boost flexible cast to go back the other way. And things get a little bit more interesting when we might do something like, a template to help us make properties. Like what if we had a property type, like our string property type, but we wanted to have it be optional? Well, we can have a template that wraps this as an optional property type. But one thing you'll notice here is I no longer have a member variable for the name. I have a function because using standard format, that's not constexpr. And so I wanted to have this be a function instead of a constexpr member variable. And you see that will then call the t name on the other thing. But now I've broken my concept because the concept we showed over here for the property description expects name to be a variable, not a function. So what are we going to do about this? Because you see we have name here, and that t::name, we're now realizing, that could be that, or it could be a function. So we really want something like this called getName that will be able to get us the correct name regardless if the property declared it as a member variable or a function. And now here's where I'd start teaching SVNI and show a whole bunch of slides about how to do this, but it's going to fit on one slide with concepts. And this is how we figure out how to get the correct name. So we described two concepts. One has name value, that it has a member that's convertible to a string, or has name function, that has a function that if you call, it's convertible to a string. And then a concept for it has a name, that it's one of those two concepts. And then it's really easy to write getName. We can use concepts. We write one getName that the template uses the has name value concept on the t. And so this will only be available for things that match that concept. And then we can call t::name and return a value, or one for functions. And it's just this. I probably should have left the old code for the SVNI in there, but it was so many slides, I didn't want to go through those because I'd rather show you new concept stuff. So again, if we look at some button property, now that we've seen what the properties look like, let's look at kind of a bigger example of a class. So for button properties, we might have text, we might have background color, border width, and then we collect all of these into a property list, which you could use tuple for this, but we decided just to use our own empty struct type for the property list. It looks like this. And I thought it was a little bit useful to be able to differentiate our property list from any sort of tuple-y thing, just to make sure people write consistent code. So one person does use property list over here, tuple over here, my own empty struct over here. And so we declare this property list, and then pass that with CRTP into this has properties that will do all of our meta programming magic to synthesize our properties. One sad thing is I really wanted all these property declarations in this namespace button properties and the property list to all be within the definition of the button class. But that's not possible. I'd have to really dig into the standard to understand why, but essentially when you're using CRTP, when I pass that button in, at that point in time, other member types, like if I had that using list in here, it's not there yet. Unfortunately. So that's why we have to put this in this other namespace. Again, meta classes would make it work how I want, but this is good enough for now. And has properties looks like this. It has a get property that takes a property description. So you can only call it with one of our correct property types, not just int or something in the template. And it has this requires property list has type. And so this is going to make sure not only are you passing in something that's a true property type for like our button, like our label text, but that it's actually one of the property types that exists on the button and that's passed in for the property list concept PS. And I'll show you in a minute how we implement this. And the same thing for the set. Again, we're going to put a requirement that you can only call it with a property description that is actually in the list of properties for this button class. Yes, please.
Okay, so just to check, has properties, I would have thought has properties would have been something like a concept. You'd say this thing has properties. You're saying, oh, it has these properties. It's not a sort of a query, sort of.
Yes, and yeah, and this is something, and thanks for bringing it up because adding the concepts, I probably actually want to rename basically everything in this library because before the concepts, has was a term in this library for mixins that you have a capability. So there's has properties, there's has can focus, as in can you hit tab and focus that control, or has accessibility and things like this. And then there's is tests as well. So that's what has properties. You're making this thing has properties, and the has properties class is what gives them to it. But yeah, I admit that's a bit confusing. And if you have confused about the names as this comes up, that's why I've not opened a PR for this yet, because I'm not fully satisfied on introducing the new names for these things, even though I have the more full implementation locally. And the way we check for this property list concept is pretty easy. We make a function that we don't define that is templated on a list of property descriptions and takes a property list. And so this is basically saying this property list test function, you can call it with a property list, and only if every parameter in the parameter pack, every type, matches the property description concept, because all the TS is property description. And then the property list concept just requires that you can call this test function. There might be a more elegant ways to do this, but that's what I came up with. And then we have a check for is something in the list. We have this inline bool that calls this function is type in list, which just uses a fold expression. How many people in the room are familiar or have used this ... fold expression syntax? Not so many people in the room. So this is a really cool feature in C++ that 17, and I believe it was added, that lets you essentially, or maybe it was 20, I forget. 17, yes. Yes, actually, right, because I remember the 17 talk, I didn't actually use fold expressions because I hadn't learned them yet, but I changed the talk to use them last time because we did have them. So essentially what this means is I had the same as or ... It's going to stamp out for every type in that LTS parameter pack. It's going to do same as T type, or same as T type, or same as T type, or, and you can put the dots before or after, and that just is, shows you where the parentheses are going. It's a very useful technique, and we'll see later. You can also use it for chaining function calls together. It's pretty cool. Basically, in the past, you'd have to use recursive templates and kind of very Lispy stuff, which I like to pop things off one at a time and do things. But if you're ever doing that template recursion where you're popping one type off at a time, try to reach for these parameter packs, fold expressions instead. And then here's what it looks like, the new API. If we're setting properties, set text, we just say the type of the property type, text or BG color, and pass the value. We're no longer repeating ourselves. So we've made that nice change where we're not going to make mistakes when we're setting properties by having the type and the string of the type correct. And then because of that, these requirements on the get and set here, what that ends up doing is essentially enforcing that only these specializations exist. It's impossible to call get property on any other type, with any other type other than the ones that were in that button properties list, which was text, BG color, and a couple others, but they don't fit on the slide. And so how do we actually implement this? So if you'll notice the get property, we're going to essentially use this property holder, which I showed you kind of the not safe imperative API. We're going to use that, and we're going to call get property and use our get name function we invented earlier and create that property and assert that it succeeds, as we know it's only going to fail if that property already exists. But since we're declaratively doing this, we know this is all going to work. And so we've kind of wrapped all this kind of stuff that could possibly fail in this meta program that we know because we declared these things, it's not going to fail because we're not going to declare the same thing more than once. And I'll show you actually how we create those properties later. And the same thing with set. That get property, we know it's going to be there, the name, because we're going to create every property we need. And same thing with set. We know this is always going to succeed because we're not going to be able to call set because of the concept requirements on anything we haven't created the property for. And again, I'll show you next how we actually make sure that all those properties do get created. So here's our get and set properties. And then when the has properties is constructed, we call this create properties function and pass it the properties list. And you'll see that create properties is templated on the property description. And so that's how we're going to pull out every property type in that property list. And from that, we're going to then call, again, use the fold expression. So for every type in the property list, we're going to be folding over the comma operator. So create property, comma, the first type, create property, the second type, comma, and so on. And so we'll be calling this create property function for every type in the property list. And then this will use the property holder create property thing where we'll call get name on the type of the property, get of the property, get name on the type of the property definition, pass it a default value. Of course it succeeds because we're not going to do this more than once for any type. And default value. This is kind of similar to our name example. What if I want a default value that's not constexpr? I might need a function here as well. So we really want something like this again. And again, this is really beautiful with concepts. We don't need any crazy sphenii. We have has default value. Has default value requires that the default value member is convertible to a standard string. That is a typo. That should be, I'm sorry about that. That should be to the property type. I copied a earlier step of my Git iterations, and that was not the one I was supposed to show here. But imagine that says p : property type, where it says string. I apologize for that. But assuming those are implemented correctly, then again, this slide should, I'm sorry, copy pasta, messed that up. Anyway, this is get name. You can imagine get default looks exactly the same, but says default anyway. And so how we use this is that create properties is then going to call something called, like, after calling create properties, it'll also need to set up the signal to know, did this property change? So we'll have this connected set that's also called from, we don't see it here, but the next thing we'll add is connected set for create property. And we'll do a few things like, so when we're connecting this thing up so that this land will fire anytime the property change, and we'll call a did set method, we'll call set needs layout, and we'll call set needs display. But there's a couple problems here. What if my class didn't implement a did set method for that property and doesn't want to call back? This will not compile. What if I'm not using this on my normal view that doesn't have set needs layout, set needs display? It won't compile. What if it is my normal view, but it's not a property involved with the display? It might be a controller that I'm connecting. The controller changing itself does not necessarily mean you need to relay out the UI. So we want to conditionally do these things if those functions are available on this, and we want to do it only when actually necessary. So for the did set, we want to do, if it's there, that means the class says, I want to be notified. So if did set's there, we're going to call that one. But for set needs layout and set needs display, we want a way to say that these properties are a layout property or a display property. And declare that as well in our property definition. So a background color, you can declare as a display property. And then anytime you change that, it will know, it's a display property, we must repaint. Text could be a layout property and a display property, because text could change your layout if you change the string, and you might need to redraw. And you combine the two concepts together with a UI property. And then any of your properties that we described before, if you inherit from these, and I'll show an example later, you automatically get, the meta program will say, you're a layout property, therefore when you change, I must call layout on or needs layout on the thing that you're working with. So what the new version of this looks like is To conditionally do this, we'll use if const expr. If you're not familiar with some of the magic of if const expr, it's not always expected that everything needs to compile. Like I said, the did set may not exist, but since it's in this if const expr block, if we don't actually enter that block, that doesn't need to compile. But there's a trap here. That's only true in templates. If you use if const expr in a normal function, all branches must compile. I don't know why, but that's the way it is. But in templates, it doesn't have to. So you'll see, you have a few blocks. So if const expr, and we'll see how these are implemented. We see, oh, does the derived class have a did set for p? If so, in our callback, we'll call this did set and pass p as just an empty struct to provide the every did set is just like an empty struct of the property type to just know, oh yeah, I'm overloading on that one. And then we're going to see, okay, is this property something? Does our type that we're working on does it have a set needs layout? And is the property something that's derived from display property? If so, call set needs layout when it changes. And then again, if has set needs layout, I am such a better proofreader when things are on the screen and there's such a big font. My eyes must not be good. So, yep, switch those. Obviously, if it's set needs display, you should call set needs display. And if it has set needs layout, you should call set needs layout. So these two function calls are backwards. Sorry, I will correct these slides after the talk. I apologize. And then we're checking if the property derives from that type. So it's both, does the property type want us to call this? And then can we call it in the class? So the two checks we're doing. And then how we will use this stuff, you see now text declares from UI property, background color declares from display property, border color and border width are also display properties because we're going to need to repaint for those things. And this is where we kind of saying is our final destination is instead of declaring all this verbose stuff, which you can do sometimes and you might want to because also the cool thing about this is you can also do meta programs to generate properties. Like our button class in actuality is the Cartesian product of every like mouse interaction state of the button of hovered, pressed, inside, outside, active, inactive for every color and picture possible. So if you want to do some meta programs, you might do this by hand. But we made this nice little macro that will essentially expand out to all this stuff so you can much more concisely say things and don't even necessarily need to provide names for things because the macro can do this for you as well. And again, remember I said the did set just takes the property type as a argument for the overload resolution. So what is next? The meta reprise. So once we have C++29 and hopefully the code generation for reflection comes in there, then I'll probably be back at CppCon again, doing this talk yet another time, and this time it'll be the actual pretty version that I wanted using meta classes, and hopefully that will also compile maybe faster than this template stuff too. I have not benchmarked the concept stuff yet compared to the template versions. Also didn't quite seem fair because the real versions of this in our code base are much more complicated. Like there's not just one version of deserialize and serialize, but there's special magic versions that let us deserialize function pointers and blah, blah, blah. I can talk about it if people are interested. But that's where we're going with this. And just backing up, because I didn't actually show the example of it, this has set needs display and has set needs layout and has set did set. We implement these the same way as and these other things for having a function is just, concept requires, does that function compile? And for the case of did set and set needs display, we don't even care about the return types. So thank you very much. What are your questions?
Thanks, Roth. Two questions. One of them, I didn't quite understand why you just needed on the set value. I think it was a couple slides back. You just gave a default value when did set happened. You gave just a default T. I kind of missed that reasoning on that.
Oh,
yeah, did set, yeah.
So it'd probably be easy. Now that I think about it, I probably should have showed an example that had more than one did set. But essentially, the way the overload resolution, so you might implement did sets for some subset of your properties, and they each of them take the. Actually, let's go do the example. Let's go back to the earlier example. It doesn't have all that noise. Yeah, here we go. So in this example, we only have one did set, but the argument to did set is the type of the property, this button properties text, which is an empty struct. And that's purely for overload resolution. So if I had another did set for background color, so when I'm passing...
So it's a tag, really.
Yeah, so it's tag dispatch, exactly.
Got it.
So then your question was from... Someday I'll put numbers on these slides.
There you go.
Yeah, so we're passing a default constructed copy of the property type here to do the correct overload resolution. And
Yep, makes sense. So second one is on the layout and other things and the setting up. How do you handle errors? I saw there was an assert there, and I'm like, that seems interesting to when you're going through each of the items. Yeah, success, assert. Cool beans. What happens? Like, is there a better way to handle that, or does this work for what you're?
Oh, so basically that assert is the kind of assert that we like to write because it should never happen. Because I can mention the other APIs, but in the case of create property, this will fail if a property with that name already exists. But with our I should have more error checking to check the names are all unique. So actually, that is the fact of putting all this stuff declaratively in one place so that we have like this has avoided that. We've never actually made that mistake because all the names of the properties are in one place. But you're right. Actually, the other check that we should be doing is verifying that there are no duplicate names.
And you could do that at compile time, and that's pretty awesome. So,
Yep. Especially if we are not using STD format, but FMT, and it could be all context per. But yeah, thank you. That's actually so. The other ones for the get and set where we have the asserts. Here that we know will never fail because we know this get property only exists because it's in that property list, and we've created a property for everything in that property list. But yeah, the duplicate name one. I don't think anyone's ever hit that assert, so I never actually wrote a compile time check for that. But thank you. You found the one hole in my compile times error checking. So hopefully I'll Slack someone afterwards to remind me to actually fix that. Yes, please.
Yeah, hello. I was wondering, when you do the set properties, you have to set it like in different lines. Have you considered of using set properties with variable arguments? And then with the default expression, you would just call, let's say, all the set properties one by one. Then in that case, you can just put the properties in any order, so the order wouldn't matter, and maybe it's just even clearer.
Yes. So you thinking of using a variadic template? So
Yeah.
That's an interesting idea. So there's a utility function that I forget exactly what it looks like that one of my colleagues made to kind of abstract away the set properties, where you kind of pass it in some dictionary of stuff and it calls set properties internally. And I was never a really big fan of it because it actually didn't save that much typing. It was just different typing. Yeah. But this version, that actually, I think that's interesting because that actually might be worth trying to make it less verbose, set more than one property at a time.
Yeah.
I think the only concern would be if you do too many and there's implicit conversions between the underlying types, like you could put the values in the wrong order potentially, but I do like this better than the other abstraction made, so I might try implementing it and actually see what it's like.
Yeah, I don't think in this case the order wouldn't matter because let's say we'd have an overload for each set properties, and then they would just be called in sequence in the default expression. So.
Yeah, I hadn't thought about that, but I do like that better than the other abstraction a colleague made, so I might try writing one later and see how it goes. So thanks for the suggestion.
Great.
Do we have any other questions? All right, and I know often it says, in my profile and bio that I work on digital audio stuff, and sometimes I use real audio examples, but today we're talking about UI. If anyone wants to talk about audio stuff in the hallway, I'm around and love to talk about that too. And here's my contact info if you want to reach out. Thank you very much.